The Boat River problem. This problem is known to almost all the students who might have completed their chapter on kinematics, that is motion in a plane. What we are going to do today is just take a small sneak peek into this problem and understand what the problem is, and also learn how a simulation on the problem can help you understand or can help you work towards the solution to the problem. The problem is like this. There is a person on one of the banks of a river. The water in the river is moving with some uniform velocity, and the person wants to cross the river from one point on the bank to another point on the bank. Now he has got two options. He can choose a particular approach which will help him reach the opposite bank in the shortest time. This is one situation. He can also work out a method by which he can reach the opposite bank while covering the shortest distance. So one is shortest time, one is shortest distance. Do both the approaches actually result in the same solution? Is the shortest distance path also the shortest time path? If yes, why? If no, why? Let us try to understand that using the simulation. Okay, so here is the simulation that will help us understand the Boat River problem. I'll tell you first of all what all these quantities are, where to look at and all that. So this is the boat that you see, right? And this arrow here with VB indicates the velocity of the boat. This one here, VR, indicates the velocity of water in the river. And this is the resultant velocity of the boat as seen from the ground. So this is the velocity of water in the river, the value. This is the velocity of boat, the value. And this is the angle made by the boat as it leaves the bank, the angle with which the boat leaves the bank with respect to the bank, not with respect to the normal to the bank, with respect to the bank itself. There can be two possible ways of taking the angle. I have chosen this one. Then what do these quantities on the top indicate? This gives you the x component of velocity of the boat, the y component of velocity of the boat, the horizontal drift. It means the person wants to go to the opposite point on the bank, but because of the velocity of water, he will end up somewhere there. That is called as horizontal drift. And this is the displacement, right? The shortest distance between his initial point where he leaves one of the banks and reaches the other point on the other end of the bank. And this is the angle made by the displacement with respect to the normal. And this is the time taken to cross the river. Right? So these are all the parameters. I will clear all that. And instead of choosing such a high velocity of water, let me decrease the velocity of water. You can see that the computer in this simulation is plotting the new values itself. And let us choose that the velocity of the water in the river is 10. You might have also noticed that the flow in the river has decreased, right, significantly or correspondingly. So let us say the boat leaves the bank and it moves along this path. Right, so you can observe all those quantities changing there on the top. So when the boat velocity is 20, when it leaves normal to the bank, right, and when the water velocity is 10, it takes 16.5 seconds to reach the opposite bank. Let us write it here. T1 is equal to 16.5 seconds. So how did the boat start? It started off normally. What is the displacement? Let us write down the displacement also. S1 in this case was 371.19. 371.19. Let us call this as meters. So we will reload it, bring the boat back, and this time choose a path that will enable the boat to reach the opposite bank right opposite to where it started. For that, you'll have to tilt the boat towards left-hand side a little bit. So we will tilt it, and you can see that, yeah. So now you can see that the resultant velocity is right across the river. Therefore, if you allow the boat to move, the boat is angled. The boat is trying to go in this direction, but it ends up going exactly opposite as you can see in the simulation. Now, look at all the values. The boat has definitely crossed the river along the shortest path. You see that the displacement now is 332.55 meters, which is definitely less than 371.19. But decreasing the distance, did it decrease the time? No. In fact, it ended up increasing the time. So what is this puzzle? This is what a simulation will help you, right, in understanding the concept. So we have to develop the mathematics for it, of course, right? Because the simulation is only a visual aid. But then we will develop the mathematics later on. This video was just to help you understand how a simulation can aid your visualization, right? Thank you very much.